Okay, lesson 5.3 video 2 is factoring quadratics that are in the form ax squared plus bx plus c equals y when a is not equal to 1, meaning you have an actual number here. It's not some understood 1 or anything like that. Quadratics in this form where you have an x squared term, an x term, and then a constant are in standard form. So anytime we ask you to put something in standard form, we're asking you to make it look like this. And you'll have actual values, actual numbers for your A, your B, and your C. All right, so in order to really be able to do this, you have to think about where the numbers come from when we multiply binomials. Factoring is just like multiplying in reverse. So when we multiply two binomials, we multiply this first term times the first term here, and that's where that A comes from, right? If this were 2x plus 1 and 3x plus 4, then that 2x times 3x gives me 6x squared. That's where that A comes from. Then we would say 2x plus 2x times 4, and we get an 8x. And then we would say 1 times 3x, and we get a 3x. And then we would say 1 times 4, and that's the 4. So the A comes from multiplying this value times this value. The C is also easy to see. It comes from multiplying this last constant times the other constant. The one that's difficult is B, because our B value comes from combining the terms you get when you multiply the inner products and the outer products. So multiplying this 1 times 3 gets me 3x, multiplying this 2x times 4 gets me 8x, and adding those together gives me that B value. So in this case, my B would be 11x. So what we've got to do is figure out how to undo that, how to pull those apart into two binomials. So the first thing you're going to do is take this function and set it equal to 0. So instead of your f of x, you're just going to make that be a 0, because we're trying to figure out what are my x values when y is 0? What are those x-intercepts? The next thing you're going to ask yourself is there a GCF? Always check that first. If there's a GCF, you better go ahead and factor that out. Well, I've got a 6x squared, a 62x, and a 72. The first thing I notice is that all of those are even. So I've got a 2, and I can factor that out. When I pull a 2 out here, that leaves me with 3x squared, 62 divided by 2 is 31x, and 72 divided by 2 is 36. I've still got that equal to 0 here. Now the next thing you should look at is look at your A value and your C value and see if they are prime. Remember that prime means it's a number that can only be the only factors are itself and 1. So the only factors of 3 are 1 and 3. If you have a prime A, that means you can lock in those factors. And what I mean by that is you're going to have your 2 still out front, but then the only way you could get that 3x squared is to say 3x times x. That's the only place that A value could have come from. All right, now the next thing you need to look at is, do you have pluses or minuses? Because that's going to determine whether I have a plus or a minus inside here. In this case, I've got nothing but plus, which means it's going to be 3x plus something, x plus something. Because if I had had a minus here, then I would have seen some negatives somewhere in my equation. All right, now it's a matter of guessing and checking. I've done all the stuff that I can know what's going to happen, so I've got to guess from there. Try different factors of C. So your C value, let me write this over here. Remember, your C value in standard form is this last constant. In this case, that's 36, because I've got a 36 right here. So I've got to think of all the different factors of 36. I recommend making yourself a little list and working off of that list. So, for example, 1 and 36 are factors, 2 and 18, 3 and 12. I'm just going through my numbers and seeing, okay, what can I multiply by 3 to get 12? Well, 36. 4 times 9 is 36. 5 is not a factor of 36, but 6 times 6 is. Once you get to the point where you've hit the same number again, the next thing that's going to be 36 is going to be divisible by is 9, and I've already got that there, so I don't have to list that one. All right, so these are the things I can try. There are a couple little hints that can help you along the way. Factors that are closer together are luckier, so when you make your list, go down to the bottom and start from there. I don't know why they end up being luckier, they just are. I find that they work out more often than the others. Also, if the original doesn't have a GCF, meaning we've already factored out the GCF here, so none of your binomials should have a GCF. I'm not going to put a 9 here, because if there's a 9 there, then I should have factored out that 3 before. So make sure you're not putting anything with a GCF in there. Again, if you forget that, it's not going to be a huge deal. It's just going to be another thing you have to guess and check before you move on. So the things that are closest together are 6 and 6, which means the first thing I would want to try is I would want to try plugging in 3x plus 6 times x plus 6, because those are my terms that are closest. The problem is 3 and 6, they have a GCF. Those are both divisible by 3. So I know that's not going to work because I've already factored out my GCF. So the next thing on my list would be to try 4 and 9. So I'm going to go over here and I'm going to try 4 and 9. When I multiply 4 and 9, or when I plug those in, 3x times 9 is 27x. 4 times x is 4x. 4 plus 27 is equal to 31. That means I've got my answer and I'm done. So let me go a little bit slower and show you what I mean by that. When I have 2 times 3x plus 4 times x plus 9, if I multiply 3x times x, I get 3x squared. 3x times 9, I get 27x. 4 times x is 4x, and 4 times 9 is 36. I've still got that 2 out in front, so I could distribute that, but really, as long as I get that 3x squared, 27x plus 4x is 31, as long as I've got those internals correct, I know that distributing the 2 is going to get me back to my original answer. So that means I'm ready to solve. Guys, the reason I only checked that middle term there is because we already know that 3x and x are going to get me 3x squared. That's how we decided what to lock in here. We already know that 4 times 9 is going to get me 36, my C value. That's how we decided what to try. So the only thing I really need to check are my outer products and my inner products and see if they add up to that B that I'm looking for. Okay, so now that we've got it factored, we're ready to solve. Remember that in order to solve, you're going to take your factored form and you're going to set each factor equal to 0 because this whole thing is equal to 0. So 2 equal to 0, well, no, it's not. That doesn't represent a solution. 3x plus 4 equal to 0, though, I can solve that and get a solution, and also my x plus 9 can be set equal to 0. When I subtract 4, I get 3x equals negative 4, and then I divide by 3, and I get negative 4/3, or negative 1.3 repeating. Over here, I subtract 9, and I get x equals negative 9. So if I were to graph this thing, I would expect to see x-intercepts at negative 9, 0, and at negative 1.3, 0. If I'm just solving it, then my two possible solutions are negative 1.3 and negative 9. All right, that is it for me on this one. You're not going to have U-tries just now. You're going to wait until after video 4, and then you'll get a U-try that's got a bunch of different kinds of problems. So let me go ahead and switch over and do the next video.